Hello and welcome to Melbourne CocoaHeads number 145. We have a lot of talking and things to do tonight, so let's jump straight into it. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. All right, so Melbourne CocoaHeads number 145. On the screen there, you can see all of our usual communications channels. The one that I recommend you memorize first, or only if you need to, if you're new around here, is the website, melbournecocoaheads.com. You can find the links to our meetup pages with all of our upcoming events, the Slack, the Melbourne Cocoa Twitter account, and our YouTube channel, all from our website. For tonight's event, we've got two presentations. Daniel Sloan will be taking us through SVG, pencil kit, and language first up. And then I will be taking you through some custom publishers with Combine. Apologies, you will be hearing a lot of my voice tonight. You may want a few more drinks to help this go down easier. And then, as always, after the event, we'll post a Zoom catch-up link on Slack. You're more than welcome to join us for, post meetup socializing. So some of our upcoming events, some of our other upcoming events. We also have a drinks night that is done in person on the last Tuesday of the month. So the next one coming up is Tuesday the 27th of April at 6 p.m. Jump on to Meetup or on Slack to find out the details and location of this month's one. We're usually pretty consistent now, but it's still great to jump on Meetup and check to make sure you're at the right place. And don't forget to check out some of our other sister groups, like Sydney CocoaHeads, the GDG Melbourne, and the web groups. They also have events that are running, back up and running again. Everybody seems to be back in the swing of things this year, which is really great. So there are a lot of good communities out there that we recommend you check out, especially while you can still connect remotely to any of the ones around Australia or the world, for that matter. Don't forget, we do most of our dealings with everybody in the community itself on Slack. We have about 900 members on Slack at the moment, which makes us one of the most active Slack teams in Australia. There's a few good channels on there in addition to general. There is the meetup channel. We chat about the meetup, so hopefully you're all in there tonight to ask any questions you have of our presenters or to discuss the meetup in general. We have a volunteers channel for people who want to help out with the organization of events. We have a jobs channel for people who are looking for work or looking to hire. We have a speakers channel for people who would like to do presentations at these events, or to get bounce ideas for presentations, or to get mentoring, that sort of thing. There are also a great number of technical channels devoted to any topic you can think of, like Swift and AppKit and everything else that the community feels is good to talk about. I spend a lot of the day in there. There's always a good place to ask questions and to meet people. We have a code of conduct. We, as always, strive for our community to be providing a safe place that's inclusive for everyone, regardless of any of the things that people usually discriminate of in the corner there. If you are being harassed, or if you notice that someone else is in an uncomfortable situation, or you have any other concerns, please get in touch. There are a few different methods of getting in touch listed down the bottom there. The type form 1 is anonymous if you wish to remain anonymous, but definitely recommend you check out the website melbournecocoaheads.com. There'll be links to the code of conduct in more detail there. So there's no the month that was this month. Everything's been thrown together at the last minute for this month, with the exception of Daniel's presentation, which has had a lot of work into it, so I'm looking forward to that one. But the big announcement for this month was that WWDC is back for another year. No surprises there. It's again fully online for 2021. Probably no surprises there either. I don't think anybody was expecting people to descend on San Jose and go back to in-person events just yet. So June 7th to June 11th. Same deal as last time. Jump on apple.com and register. Make sure you get your invites and of the developer apps and blah, 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 blah. The big speculation this year, obviously, from the images that have been shared, is that Apple Glass might be launching. I kind of feel like that's a little bit too obvious for Apple, personally. They tend to have a little bit more subtlety in their invite emails and stuff like that. But honestly, who knows? I'd love to be wrong about this one. Nothing would be better than a pair of Apple glasses for myself, I guess, in June. No one's came forward with any apps that we shipped this month, but the community is still very active. So if you've shipped anything in the last month or so, or even before that, or you have an app that you want to tell us about, let us know on Slack. You can either use in the Meetup channel as listed there. There's also a Your Apps channel where people usually post whenever their apps go live and that sort of thing. So it's a great way to see what the community is actually working on and building. As always, we have a big thanks to our sponsors. We couldn't put these events on without sponsors, especially this year, and especially last year. We'd like to thank our sponsors for sticking with the community and staying on board and supporting everybody during these tough times. So thanks to our gold sponsor, Itty Bitty Apps, and our 3 silver sponsors, Latitude Financial, REA Group, and Cognizant. Big thanks to everybody from them. All right, so that's the introductions out of the way. Let's switch over to our first presentation, SVG, Pencil Kit, and Language from Daniel. Daniel, if you can share your screen now for me, we'll get started.
Hey, I am Daniel Sloan, and today I'll be talking about SVG, Pencil Kit, and Language. As you can see, I have different languages on the screen. They all happen to say the language it's written in. So, for example, studying Japanese. So the issue and what we are trying to achieve. A problem most beginners of a language face, regardless of if they're first or the fifth, will be learning the language character set. At WWDC last year, there was a Pencil Kit handwriting tutor app video. This handwriting app was, however, based on the English alphabet. The engineer had to hand draw the characters before exporting them out and into this app. So I thought this would be a perfect way to explore integrating a different language character set that might be available in the SVG format, such as a kanji character set. While I could draw this like the Apple's engineer did, this would take forever to do because the amount of kanji. There is a public repo with a full set of kanji and correct stroke order in SVG format. So I thought we could probably turn this into PK drawings since we can parse SVGs and each of their paths represent a stroke. So what is Pencil Kit? Pencil Kit makes it easy to incorporate hand-drawn content into your iPadOS or macOS apps. As we will find out, we can do SVGs as well. What is PK drawing? PK drawing is a finalized drawing that is from a user automated from stroke data. A few ways the drawing can be initialized are by strokes, data, and decoder. So let's take a look at some of the code. We'll just start here at this SGD path, and we're passing a resource. I've just created a function because I'm reusing a couple different places. So I've created an SVG parser. It's just a basic XML parser, and nothing fancy there. And essentially, it will return back just an SVG model that I've created. So just some basic properties in there, such as path, the kanji, size. Also, we get passed back in string format. So if we take a look at one of the SVG's source code, we can see what path actually looks like. This right here. And we particularly want this data here on the D. This tells us how the paths are drawing. So when we get the path back via the string array, we should just map it into an SVG path, which is just a pod that I've taken just to make things a bit nicer and quicker. I don't have to worry about what each pod does. I mean, what SVG paths do, per se, at that point. And so when I map it over that, it just brings back an SVG path that now we can turn into a PK drawing. And so with the PK drawing, we need to do a few things before we end up with the final product. So with each path, so I just created an extension on the array for what each element is the SVG path. So with the path, if we loop over it, we just need to turn it into a CG points. So with the CG points, essentially we need to map over that data. First, we need to grab the move command, and that will be our start point. And we just need to pin that into the points array. And then afterwards, we just need to loop through the rest of the commands. We only really need to worry about cube curve here. I'm sure some of the other commands you could work into what you need to do for your use case, but in this particular use case, cube curve is what we're going for. And we need to actually write our own cubic Bezier curve that returns CG points back, because we need to fill in between certain data points. I can actually show you the data points here, what they actually represent. So if we go over here and look, we have what is the two anchor points, left and right, and then we have two control points. So this actually determines the drawing, like the line. So they're actually notated as P0, P1, P2, and P3. And we just need to put in this set equation here. I'm not going to go into this equation. It's pretty straightforward. We just need an X and Y. They're both the same, except for one being X points and one being Y points. And so when we go over it, we just need to, at the end, set the right anchor to the start point. That way we get the new start point for the next loop through. And so if we come back down to the PK drawing itself, we have the CG points. It's just mapping to stroke points. And then we create a stroke path, PK stroke path, and then PK stroke. So I've just put in a couple like marker here, green, a couple data points that doesn't exactly affect what we need to do for this particular display ground. So if we run it, we should see the drawing itself. Takes a moment. So now, if we go look at this first one here, over here in the resources, we actually have now taken SVGs into PK drawing. I need to run it, get off look. And so what's actually quite nice about this, so once we actually got it into a PK drawing format, we can actually turn it into data via the data representation. So that way we can actually save locally or save remotely. Sorry. My computer's acting up. I need to get a new M1. There we go. So yeah, so as you can see, I've decided to do data representation and show it again by taking that data and tossing into PK drawing to redraw it again. It's quite nice, you know, save out locally or remotely and don't have to worry about going through that process again. You already have it saved. And I did another one just as an example. What's next? So I will be integrating this with the full kanji set. I already have started on it. I just need a couple more edge cases to fix up. And I'm hoping to present it again maybe in June or July with the full integration and any issues that I found along the way. And yeah, here's the sources and more info. You can find today's code here on my GitHub. Some Bezier curve equation and explanation, what I just showed. The Japanese kanji SVG set, SVG path that I use to help make parsing SVG path strings easy, and the handwriting tutor app videos that I will be modifying in June or July and presenting on. Yep, that's it for me. Back to you, Rob.
Okay, that's better. Now I'm actually on the correct camera and everybody can see me and hear me. Well, thank you very much, Daniel. That was awesome. I'm looking forward to seeing the final thing, and hopefully we can see it in person too. That would be really good. Kanji is something that I've spent a lot of time practicing myself and never really found any good tools. Looking forward to seeing what you've come up with there. Alright, so let's jump straight into the second presentation of the night, which is mine. I threw this together last night, something that I've been meaning to talk through for a long time now, based on some work I've done for a few clients in the last 12 months. Spent a lot of time doing custom publishers, and there's a lot of edge cases, which Renault has already taken us through a few months ago, but more around how you actually go about putting together a custom publisher and all of the different things you need to consider when you do that. Because there can be a lot of weird things going on in this. The first five minutes or so of this presentation will be just a quick review of the basics of Combine, because we'll need to be referring back to those as we go. So if you are familiar with the basics of Combine, now's a great time to use the bathroom, refresh your drink, whatever you've got going on there. Otherwise, let's go straight in. So as everybody knows, Combine is Apple's functional reactive sort of style thing. If you've come from an RX Swift background, you're probably familiar with all of this already, or you're probably familiar with Combine already anyway. But just to cover all bases, Apple talks about Combine being publishers and subscribers, and talking about values over time. So you could consider it as being some form of a collection where the index is actually time-based instead of integer-based, that sort of thing. Weird way to think about it, but it really does help sometimes to remember that the key ingredient of Combine that you don't normally get with straight-up synchronous coding is... So just a quick look at all of the three protocols that we need to talk about in detail later on. The core of everything that we do here is the publisher protocol, and all of these protocols themselves are actually really, really, really simple. The key thing to remember with the protocols is they do not tell you how it will emit new values, but only what it's going to emit. And that's what we're describing with the first associated type there at the top. And then publishers can also fail, and fail spectacularly sometimes, in which case we can set the failure type in the middle there. It's quite common that some publishers can't fail, like if you've got a just publisher or a sequence publisher, for example, in which case you can set the failure type never. And then the receive method is where all the magic happens, really. It tells your publisher implementation that the specified subscriber wants to subscribe to the output of your publisher. My picture-in-picture is cutting off things a little bit there. Can't do that as the audio was attached to my picture-in-picture, so it cut off. That's great. Right, so the subscriber's input, as we said, must match the publisher's output. If it doesn't, you need to do some publisher in the middle, a publisher in the middle that manipulates the output so that they do match, and the failure types must match generally too. Again, the same thing. If you have the you need to make sure that everything lines up in order for that subscriber to be able to subscribe to that publisher. Now, as I said before at the start, the protocol itself doesn't detail how you are going to emit values, only that you will theory emit values, or the values that you will emit. There is one expected behavior though, and that's when a subscriber subscribes to your publisher, that will succeed. There's no option to fail out of any of this. And then you need to turn around and provide the subscriber with a subscription type. And we'll go into that in a second. So on the other end of the spectrum, the subscriber is also a very simple protocol. Describes the types of inputs and the errors that your subscriber is happy to accept. And then it has the three methods in the middle at the bottom there that the publisher can use to tell the subscriber what's happening. So the first, the receive subscription, is the counterpart to the receive subscriber method on the publisher protocol. And this is going to get really confusing really fast. When you subscribe to your publisher, you then need to turn around and pass a subscription object using this protocol method. The second is tells the subscriber that you're emitting a value of the specified type, and then that subscriber needs to return any additional demand it might have. We'll go into demand management a little bit later on. And then the third tells the subscriber that the publish is finished, either because it finished normally but there's no more values left to emit, or that there was an error And then finally, the piece that ties them all together, you have the subscription protocol, which is used as a means for the subscriber to be able to communicate back up to the publisher. Now, some of the differences in other reactive or functional paradigms here is that they will keep the publisher and the subscription protocols together. Apple splits them out, and that enables them to do a bunch of stuff around cold publishing and hot publishing, which I'll cover in a second. But it's suffice for us to know right now that the subscriber communicates back to the publisher through the subscription by telling it any demand it wants. Like, I would like 10 values. And the one to cancel as well, which is actually part of a separate protocol called cancelable that we've I'm just combining it into for ease of use on this one. We are having a good night with the technology tonight, aren't we? Okay. Nope, that's not right either. That one. All right. So a really quick example of what's actually going on under the hood here. If you had a publisher of a sequence, in which case we're passing an array of 2 string values, hello and CocoaHeads, and then we subscribe to that with the sync subscriber, this is what would actually happen under the hood. The sync would send to the sequence, sequence being a publisher, calls the receive subscriber, passes itself in. The sequence then initializes its whatever it's using as a subscription type, and it will pass that back to the subscriber, the sync, using the receive subscription. The sync then requests demand from the publisher, or from the subscription, sorry, and then the sequence will then turn around and emit the 2 values that it has, hello and CocoaHeads, to the subscriber, and then obviously the because it's a finite length array, it will complete the publisher. Completion comes through as normal. Cool. So just one last thing to mention, in the Apple has what they call operators. Now, the operator is just a method that is defined in an extension of publisher that returns another publisher. So most often you'll find that operators don't actually do any manipulation themselves. They pass that off to another publisher, which actually has all of the logic inside. So map is the most common example, which has a transform function that will transform the value of any values that are emitted to something else. But that's actually done using publishers.map, not using the .map function on publisher. And one last thing before we dive into doing a whole bunch of custom stuff is the notion of hot versus cold publishers. Now, this catches a lot of people out, me included. So cold publishers will wait for demand before emitting any values. And they usually respect that demand. Not always, but they'll usually respect that demand. And you'll see why when we build a custom publisher, why that can happen. Whereas hot publishers don't care about demand at all. They start emitting straight away, regardless of who is listening or who wants to receive any of the values. And unfortunately, it's not always obvious which publisher behaves in which way. It actually can be quite frustrating at times because of a lot of Apple's built-in publishers are hot publishers when you don't actually expect them to be. And again, Combine assumes unlimited demand in a lot of common places as well. So, for example, the sync subscriber, in fact, all of Apple's built-in subscribers are unlimited demand, which can make working with anything that's not unlimited demand very, very frustrating. So the example of this that usually trips everyone up is Future. Future is a hot publisher. And the moment that you actually hook everything up, it will invoke that closure that you're passing into the initializer. The promise is completed, and the Future will emit the value that comes through. Apple's standard way for dealing with this is to wrap it in deferred. Now, deferred has, according to the docs, it actually waits until it's got a subscriber and it's got a demand from that subscriber before it invokes the closure that's passed in. So the future doesn't get created, and therefore it doesn't execute until there is demand coming in. And if you're attaching a sync, the first thing sync does is request unlimited demand. And you can see in the little drops in the events there, the difference is that it does do that wait. All right, so custom publishers. There's three ways to do this. We'll go from simplest to the most difficult. But the easiest way is to just wrap your code in a custom operator. Apple strongly recommends mixing and matching existing publishers for new behaviors rather than trying to build your own. And so often you'll find that the easiest way is to mix in an existing publisher or a subscriber or multicast, whatever it is, tools that you're finding do the job for you, and then wrapping it up in a custom operator and slinging it off. The step after that, this is especially good if you need to mix and match with imperative code, is to wrap it in a custom publisher. And then finally, the last step is to go fully custom, emit everything all yourself. And we'll do an example of that. So, simplest approach for a custom operator, right? It really just takes an existing publisher chain that you've built. So in this example, we are emitting a string URL. We're doing some manipulation of errors to make this all actually talk to each other. And then we're flat mapping that through a data task publisher, which obviously is going to emit some source code, hopefully, or an error as it goes. And then maybe we print out the source code, or we're going to do something else with it. Don't try this at home. This is a very contrived example, and is definitely not best practice at all. But it does have a flaw, deliberate flaw, in that using flat map here is probably not what we want. Excuse me. In this case, it's okay because our publisher at the top, the just publisher, emits the value once and then completes. But if our publisher at the top was a sequence, for example, or something long-lived, like you were getting it you were taking a URL, for example, from a website or from an API to then fetch images or something like that, there's the possibility that that website could emit multiple times, in which case the flat map would be executed multiple times, and suddenly you would have a bunch of sources coming through that you weren't expecting. Apple provides an operator to get around this. They provide the switch to latest, which takes the most recent publisher from a publisher of publishers and switches to the last one. But basically what it means is if we get a new one is emitted from the just at the top there, the existing data task publisher in this one would be cancelled, a new one would be started, and then the values from that one would be emitted down to the subscriber. And the subscriber would be none the wiser that the publisher in the middle has changed. So this is a common pattern though, but it's not as convenient as just reaching for flat map, which does, in theory, if you read the documentation, it does what you want it to do. So it's really easy to actually, forget that this is a thing. So let's pull that actually out into a custom operator. And custom operators are a great way to simplify and reuse the built-in publishers for common patterns. And not only can they make things easier, but they can also enforce best practice and help eliminate common mistakes without really changing the structure of your code. So here we have, in an extension of publisher, we define a flat latest operator, which takes in that same transform that flat map was dealing with, in which it accepts a value input and emits a new publisher. But instead of doing having all of this built into two methods, we then do the map and the switch to latest all in line. So it actually comes back a lot closer to the original code. Instead of using a flat map, we're now just using flat map latest. Both will show up in autocomplete, so that when you actually start typing flat map, you see both. You think about it. That's not really the primary driver, but it really can help out in publishing, exposing, making common patterns more observable, I guess is the word I'm looking for there. But you can take this a little bit too far as well. If you find that you end up starting to limit your failure types, or you're doing set failure types, you're asserting no failures, mapping errors, and that sort of thing, you're probably going a little bit too far, and you're probably getting limiting the reuse potential of this. In general, unless you're actually dealing with or an operator you're setting up is all about error handling, it's best to try and be as agnostic as possible with regards to failures, to make sure and leave it up to the consumer to then decide how to handle errors themselves. All right, so a custom publisher. So we could have done that custom operator as a custom publisher as well, but there's not really a lot of value in doing that. The difference between the two is that we would create a type, usually a struct, sometimes a class, depending on what you're working with. We create a type, we put we conform that to publisher, and then we do the custom operator work inside the receive block. But here's a bit of a better example. This is a little publisher that wraps the UI applications begin and end background task. So we have a class called completed backgrounded, blah, blah, blah. And we're defining this in terms of our upstream, because when you do publishers, especially when you're doing them as an operator, it's usually best to define it in terms of upstreams and downstreams rather than trying to define them in terms of inputs and outputs, because that can get confusing. Is it my output? Is it my downstream's input? Is it the upstream's output? So usually we use the generics on the two publishers, up and down, if we've got, or a publisher and a subscriber. And then we can always refer to things in terms of up and down, so it makes it easier to think of which way the data's flowing. So because this custom publisher does no manipulation of the output values at all, we set the output from our publisher, our completely backgrounded publisher, to be the same as our upstream's output. We're not going to change that, but we do change the failure type. If you've used the begin background task and end background task APIs from UI application before, you know that the task can expire. It's not guaranteed that we're going to have enough time to complete anything that we're doing. So if that expires, we want to be able to tell our downstream subscriber that it has expired so that they can clean up because we're about to be put into the background. So we do set the failure type to be Swift.error. We keep a reference to our upstream. Now, because we're manipulating or we're changing, not so much manipulating, because we're changing the output values type, we can't just assume that our upstream is going to be have the same failure type as us, because that's very limiting. So we support two basic ones. We have an init that we might be passed a upstream that has a failure type of error, in which case we can just store that straight into our upstream property. But often we want to work with upstreams that have no failure potentially, so the sequence or just or any of those sorts of ones. We'll be able to have a separate initializer that passes that in, and then we can set the failure type and save that into our property there as well. And fortunately, we can use type erasure for this because we don't really care what the upstream publisher is. We don't really need to know any of that information. We just care that it's a publisher with an output and the failure that we know it's going to be. All right, so hopefully this is not too small, but this is the guts of what we're going to do here. This is the same receive subscriber method that we have on that protocol. So anytime we get a new subscriber come in, it will execute this block of code. Now, here we keep a variable in the local scope, and we do that over having a property on the publisher, for example, because there's no guarantee that our publisher will only ever be subscribed to by one subscriber. We need to always remember that it can have multiple subscribers come in. So to not muddy the waters, we always keep a local variable that has our background task identifier, so that if we do have 2 subscribers to this, or 4 subscribers, or 8 subscribers, they all have their own type identifiers, and we're not potentially ending tasks that haven't started or getting a bit weird. So all we actually do here, now the trick to doing a custom publisher this way is that we don't actually subscribe ourselves to, or we don't subscribe the subscriber to ourselves. we subscribe the subscriber to the upstream directly. We're just providing the manipulation in the middle. And in this case, we have a handle events operator. Now, this one's a bit of a controversial operator because some functional purists may not like that this operator exists because it's purely there to manage side effects, really. But in the realities of iOS and macOS development, we're not 100% functional, which means we are going to have to interact with imperative code. And handle events makes this a really great way to do that. And again, we're extending the existing operators rather than building our own. And we'll go into why that's a good thing in the next couple of slides. The next slide, actually. So the handle event one, obviously we just provide in, saying obviously, but we provide a bunch of closures for the different events that we want to react to. So in the case when our downstream subscriber has successfully subscribed to the handle events publisher, which has successfully subscribed to our upstream publisher, it will pass the subscription back down the tree to our subscriber that we've been passed. When that subscription gets passed through the handle events publisher, we want to kick things off because now that we've got a subscription, we know that there's a subscriber, means we've got a task that's running. So we're a cold publisher in that sense. We don't just immediately tell UI application that we want to start a background task. We wait until we've got a subscriber. We obviously store that task identifier in the local scope there. And we also provide in the expiration handler, because that's required by the by Apple. So in the event that the background task expires, we will cancel our upstream subscription to our upstream publisher. And then we will tell the downstream subscriber that the publisher ended with a failure. The background task expired error there, you see in the middle. And for completeness, we will also tell UIKit that we've ended the event. And then the other two things that we do is when the publishing completes, either because it completed normally or because there was an error, or if the subscriber cancels out of any of this, in both of those cases, we will tell UI application to end the background task. So it's a very, very basic one. But fortunately, Combine allows us to do this without having to go the full custom publisher route. Okay, now finally, the meaty bit everybody's been waiting for. So I call this the hard way, because it can be a hard way. It is entirely possible to build a custom publisher from scratch yourself. As we said, the protocols don't dictate to you how you do any of this, how you emit values. They only dictate what you're going to emit. And as I said before, Apple recommends that you mix and match existing publishers as much as possible. And this is because thread safety in Combine can be really, really tricky to get right. Now you can see on the screen there the 3 rules that we've got for thread safety in Combine. But unfortunately, these didn't come from official documentation. They came from the Swift forum threads you can see down the bottom there from one of the Combine developers posted in response to somebody's question. It's not the best way to do documentation, but here we are. So the 3 rules that we've got is that the first one's more of a warning that a call to receive subscriber can come from any thread. Downstream calls to the subscriber's receive subscription, receive input, and the receive completion methods. So those 3 methods that we have on the subscriber protocol must be serialized, but they don't have to be on the same thread. And then upstream calls to the subscription's 2 methods, request, demand, and cancel, must also be serialized, but then they can also be on different threads. Those are the 3 rules that Combine has. If we follow those 3 rules with building our custom publishers, we're probably going to be okay, hopefully. So how do we actually do that? There's a number of different approaches. These are the 3 common ones that I've seen recommended or I've seen used. The one that Apple recommends I've actually got as number 2. Try and route everything that you do in your custom publisher through an internal subject, either a pass-through subject or a current value subject, and generally 1 per downstream subscriber what you want to do. And then you can let the subject handle all of the serialization for you, because you know that it will get it right and your publisher will be thread safe. If you can't do that, or you want to mix and match some of these approaches, I mix and match a few of them sometimes. And also, if your publisher maintains a list of subscribers, there's two methods for that. Sometimes you will pass through. I'll go into that next slide. Yeah, so if you are maintaining a list of subscribers in your publisher, say for example you are multicasting and you wanted to every time your publisher gets a new value, it sends it to every subscriber. You need to protect access and mutation of that subscriber list with a lock. And then the final approach is using a dispatch queue to serialize the calls. But remember, you need to have separate queues for upstream and downstream messaging, and usually one per subscriber is recommended as well. So it can get quite busy quite quickly. That's why everybody says just to use pass-through subject or a current value subject and just let it handle all of that. All right, so let's do a fully custom publisher. You might have noticed earlier this week, Apple dropped a bunch of new Swift collections, which is also looking very good. A deck, yeah, I pronounced it right, which is a double-ended queue, and then the ordered set, and the other one that has escaped my memory now, an ordered dictionary. So let's have a really simple class that we're going to wrap a deck type into a queue. Now we wrap this purely so that we can notify the internal subject that you see there when that queue is manipulated. So whenever something is added to the queue or taken off the queue, we can notify that internal subject. Now I've actually cut a lot of the boilerplate out of this to get all of this stuff to fit on a single slide. But you can see there's a lock there in the middle, and we use that lock then to ensure that access to, or manipulation in particular, of that elements deck is thread safe, because if you then hang a publisher off the back of this from something that's not thread safe up front, doesn't matter how thread safe your publisher is, things can get really weird really quickly. Okay, so hopefully that makes sense. Yep. Yeah, so anytime we enqueue anything or dequeue anything, we use a lock to protect that, and then we will send that to our internal subject, say that it's just a notification. We're not actually emitting the value into that subject. We're emitting a void just to say that, hey, the queue was mutated. So then we can create a custom publisher type. Now I like to keep my actual publisher implementation, so the implementation of the protocol, to be in an extension, so I can keep the type itself nice and clean. You can see here that our queue.publisher type struct is really simple. It just wraps that queue. Something you might not have noticed on the first one here is that our queue type is a class, and we do that on purpose because when we need to support multiple subscribers down the track, and we don't want to have multiple subscribers working off a copy of a struct, that sort of thing, especially when you're then having a third party mutating the struct up front, and so on and so forth down the chain. So it's better we use a reference type there. And then we add a little computed property, just a publisher, to return the actual publisher of the queue. So you can just go queue.publisher.sync.whatever, that sort of thing. And I'll have an example at the very end of how this all hangs together. So our publisher implementation is actually really basic. As per the protocol, we specify the output type. So the output type of our publisher will be the same element generic that the queue has itself. And it can never fail because we don't. Yeah, it can never fail. How that would fail in this case. So we set our failure type to never. And then we use one of the two methods here that are common. Whenever we receive a subscriber, we create an inner type. And I've seen these called inner, I've seen this called manager, I've seen this called subscription manager, or just subscription. I've seen it called a bunch of things. Inner seems to be the most common. But it's a private inner type that then handles all messaging between your upstream and your downstream. And then so we can pass our queue, because it's a reference type, and our subscriber to that inner. and then we can send that inner that we've just created back to the subscriber as their subscription. So the subscriber will then retain it, and so on and so forth. But it means that we're not keeping a list of subscribers. We're not keeping a list of subscribers, so we don't have to do any locking or anything like that. Each of our inner types will work independently of each other. That's good. That's what we want. So just a note then, though, that means if we do have multiple subscribers, they will be pulling off records from, or pulling off elements from the queue individually. Apple provides a share operator where you can use to get around that sort of thing if you need to. That, unfortunately, don't think it works very well with demand-based publishers. It assumes everything is unlimited, because a lot of Apple things assume everything is unlimited. So you might be a bit out of luck needed to do that. Anyway, so our inner type is where all the magic actually happens. Here we keep, when we're initialized, we keep a reference to all the things that we need. So we obviously keep a reference to our downstream subscriber so that we can actually send them messages when we get them, send them values or completions when we need to. We keep a cancelable, and you'll see that in a second. We also keep a dispatch queue. So the route number 3, we keep a dispatch queue to serialize all of our downstream messaging. And we try and keep track of the demand that our subscriber gives us. Unlike a lot of Apple publishers that don't give a crap about demand, we try and be a good citizen here, and actually keep track of the demand that our subscriber has. And in order to make sure that the demand tracking is thread safe, we use a lock to protect access to that demand. And we'll go through all of that on the next slide. So we won't. We'll do the slide after. So the basic initializer is we keep a reference to the subscriber, obviously, and then we don't actually. So what we do here is we subscribe to the queue's subject, so that internal notification subject. We put in a token debounce here because if someone decides to add, say, 1,000 elements into the queue in a loop or something like that, we don't want to get 1,000 notifications to say that the queue is being manipulated. We only need one. So we put in a token debounce there to make sure that happens asynchronously and gives it that chance to drop all of the duplicate 999 ones that came before it. And then we just have a simple sync subscriber, and all that sync does is it calls our flush next method on our inner. Now all of the magic happens in flush next. You'll see that we don't actually care about demand management here or anything like that. We centralize all of that into the flush next one function, which is the next slide. Yes, it is. Now, hopefully that's not too small for people. I'm going to need to blow this up so I can actually read it myself. So this is where all the magic happens, really. Now, the very first thing we do is we use that lock that we have on the demand, and we try and get a lock on that. The reason we try and get a lock on that instead of waiting for a lock on that is because we have 2 places where the flush next function can be called, or 3 actually. One is when we've received demand. One is if there is pending demand, and the third one is if the queue is manipulated. Now, any one of those can fire at any time, but because the flush next command here that we've got, the function here, will always, when it gets to the bottom, check if there's unmet demand and then start again. Doesn't matter if we have 3 or 4 of them come in. We use that lock to drop all of the second and third ones, knowing that when it reaches the end, it will come back up and start again anyway. So inside that lock, we check to see if we still have a subscriber. If our subscriber's gone away, we cancel the upstream if it hasn't already been done. And then we return none, and no additional demand. I can't use my mouse on the screen, but you can see that we're returning the result of whatever the return result is of this closure is our unmet demand. We then check to see that we still have demand, and this is happening inside the lock so that we know that it's up to date. And then if we do have unmet demand, we dequeue an element from the queue, the next element in the queue. We then decrement the demand, say that, hey, we're sending one down. And then we use that dispatch queue to asynchronously send the element that we just dequeued to our subscriber. And now from the original protocol with the receive input method, the subscriber must return any additional demand that it has. So if the additional demand that we get back is positive, we will then turn around and send that back to our received demand function. And then we return the whatever demand is left unmet on the property at the end of the lock. Now, we do that so that in the next line there, if we do have unmet demand and the demand is positive, we can use that same scheduler to re-queue the next work through of the function. It gets really confusing really fast. And this is why this is a lot of people don't bother with demand, because it's really, really hard to test. Actually, if you don't, because no subscribers that you get given built in have anything but unlimited, so it's really hard to test. But also, if we didn't deal with demand management, this would be 2 lines. This function would be 2 lines. So that's why a lot of people that do custom publishers just don't bother with demand management, which is unfortunate. Imagine if it was actually made easier to test. A lot of people would do it a bit better. And there are some tools out there. I will dig out some of the tools that we use to test some of these in the projects that I've been working on. We've had to write a lot of custom ones ourselves, though, in order to actually have a subscriber that works with demand, for example. But that's a topic for the pub. Anyway, so that's our flush next method, which is where the bulk of the magic happens. Just to round things out, we have our received demand function. So anytime the subscriber calls the subscription's receive demand or request demand method, or if we get additional demand back from sending to the subscriber's receive input method, so you have to return additional demand then. Anytime we get additional demand come through, we save it with the lock, obviously, that's there, and then we will, if there is unmet demand, we call flush next again. And so we do that in the confidence that if it's already running for something else, like we've kicked it off through 3 different routes, the lock will just stop the other ones from happening. So we're protected in that sense. And then that final piece of the puzzle then is, because we're passing our inner type back to the subscriber as their subscription, we need to conform to the subscription protocol, which has the 2 methods: the request demand, which we pass through to our existing received demand function, and then if the subscriber wants to cancel. And in that case, we set our demand to none so that the flush next will stop. But we also nil out our reference to the subscriber so that there's no retain cycles or anything like that going on. Okay, so that was a lot to get through, but when you actually use it, it's really simple. So let's say we had a queue of a string-based queue, and we take a publisher of that queue. You can see the list of events down the bottom there, which is to say that the sync, because we're using a sync again, the sync will call the receive subscriber method on the publisher, which will then get back the inner type on its received subscription method. Not confusing at all. The sync then requests demand of our queue publisher, but so it will go into start stepping into that function. Now we have a positive demand. Sync always requests unlimited. So we have a positive demand. It would call into the flush next method, but go, hey, the queue is empty, because this all happens synchronously at the moment. The queue is empty, so there's nothing, so it will bail out. We still have positive demand though, so when we do actually enqueue the string hello into the queue itself, it triggers to that internal subject that we set, which will then we are subscribed to through our debounce, and the sync on there will kick off another flush next, but this time it will succeed because there is unmet demand, because we've the subscriber has requested demand from us. Now the queue is not empty, it has a single string in there. So we'll then turn around and dequeue that string from the queue and send it to our publisher. Send it to our subscriber. I got so far through this without getting them all mixed up. Send it to our subscriber. And then obviously it will stop because the queue is now empty. And then we enqueue another one and the process kicks off again. And that's it. That is everything that I have. Hopefully nobody fell asleep. Hopefully you actually got something useful out of that. Even though it took, it wasn't too bad actually in terms of time. Still 40 minutes. Okay, it was quite long. But yeah, hopefully you got something out of that. I will post the slides in the meetup channel straight after this, and I will be around on Slack and on the Zoom that's coming up to answer any questions if you have any questions. Thank you very much. Hello, it's me again. Hopefully with everything, like I can see the audio bars are moving, you can see me on the screen, everything looks good. All right, so I hope you enjoyed our 2 presentations tonight. April seems, or March, April, around Easter seems to have been quiet time for attendees and for speakers. All of the groups that I'm involved with, volunteering for, have struggled to find speakers in the last couple of weeks, and the attendance has generally been pretty low. Hopefully you still had a good night. Right. Mental blank. Right. Don't forget that we've got our drinks night coming up on Tuesday, the 27th of April. So the last Tuesday of the month. Again, check out meetup.com for the details on that and the other groups that we have listed there. Thank you very much for coming. Don't forget to check out our website and all of our various social channels. Especially recommend you jump on Slack if you're not on Slack already. 907 other Cocoa heads. Having them around and to talk to during the day is generally very helpful. So definitely recommend you do that. Obviously, keep in touch. Follow us on Twitter if you don't already. We post all of our events there. And all of our existing videos are on our YouTube channel, including the recording from tonight, if you happen to come back and want to catch anything else. In which case, to the Zoom. We'll see you, post the link in Slack on Zoom in just a moment, as soon as the credits finish rolling. And we'll see you all over there. Thanks very much.